In this video, I want you to be able to practice solving a system of linear inequalities. So I will write down a sample problem. You should try to solve the problem, and then I'll work out a solution for you. So here's the linear inequality that you should work with. Greater than equal, y is less than or equal to 1/2 x minus 3/2, and y is greater than 3x minus 1. So pause the video and work it out. Okay, so let's look at the solution to this problem. Let me graph the first line. It has a slope, y-intercept of -1.5, so that actually should be down here. I started to plot it at 1.5, and it is sloping upward with a slope of 1/2. So the nicest thing would be to go up half a step to -1, and then start to go up 1 unit for every 2 units that I go over, or 2 units to the right and 1 unit up, 2 units to the right, 1 up, and so on. And then going in the opposite direction, I'll drop down by a half and over 1, and then I can start using a 1-to-2 ratio. Drop 1, go 2 to the left, 1 down, 2 to the left, and now I have a nice line plotted. And now, since it's less than or equal to, I'm going to actually make this a solid line, because our solution will include this line. When I look at the second equation, I want to plot the y-intercept at -1 and go up in a slope of, that's 3 to 1, so I will go up 3 over 1, up 3, 1 to the right, 3 up, 1 to the right, and 3 up. And then I'll come back to the y-intercept and go down 3 and 1 to the left, down 3, 1 to the left, down 3 and 1 to the left, and now I will put in a dashed line because the solution does not include this line. It's everything up to the line in the solution region. Now, once again, we have 4 regions to consider. Region 1 is the region above both lines. Region 2 is below the second line and above the first. Region 3 is below both. And region 4 is below the first and above the second. So just real quickly, the fastest way to do this is to consider that in the form that it's in, the y values for the first one need to be below the line because of the less than aspect of this. And in the second equation, we have y is greater than 3x minus 1. So we need to be above the second line. So we're looking for the region that is below the first line and above the second line. So it looks like region 4 is the one that would satisfy that. Remember, our second method of doing this would be to just substitute in a point. I use the point 0, 0 as my preference, and since 0, 0 isn't, it's clearly in region 1, it's not on one of the lines dividing regions, we can use it. And so if I look at the first equation, I would get that 0 is less than or equal to 1/2 times 0 minus 3/2. And 0 is not less than -3/2. So that gives us a false statement. 0, 0 was above the first line. So clearly that indicates exactly what we had before, that instead of being above the line, the solution needs to be below the first line. Okay, we substitute 0, 0 into the second one, and 0 is greater than 3 times 0 minus 1. 0 clearly is greater than -1, so that's true. And 0, 0 was above the second line, so that verifies what we have here, that the solution should be above the second line, and so it should be region 4. So we can fill in, we could shade in the region in pretty much any manner that we want. We can put arrows in to indicate that this is the region that we are most interested in. Okay. Just as a little afterthought here, since we didn't put it in the original video, if the word had not been and, but had been or instead, So if the word had been or instead of and, let's do that in green. How would that change our solution? What would that would mean is that we could be below the first line or above the second line. So instead of being restricted to things that are below the first line and above the second line, which is only region 4, we could also include region, let's see here, we could also include region 3, because region 3 is in fact below the first line. So anything that's below the first line would be true. And we could also include region 1, because we could look for anything that is above the second line. So region 1 is above the second line. So if the statement had been or, we could actually shade in that it was all of the points below the first line, actually, and including the first line, and we could look at all of the points that are above the second line. So the only thing we wouldn't have is region 2. And you can see in here that region 4, which was the solution to the and statement, is where the two or statements would overlap. We have a more restricted region when both things must be true, and a less restrictive solution when only one of the two must be true at a given time. They could both be true, or one of them could be true.